Hey everybody, Mr. Judson here. Welcome to our last week of videos. I guess that's kind of nice that it's finally here. Don't forget, CWU students, you guys are taking your final exam on Thursday. I just sent out an email reminder. If I haven't heard from you yet, you need to tell me what time you want to take the test so I know when to send it to you. Also, I will be sending it to your parents. You might want to check and see if your parents are getting the emails that I send, just to make sure that we've got the proper email address set up. Alright, so today we're reviewing Chapter 4, kind of all the way back to the beginning of integrals. And so, one type of problem we had is where they would give us the second derivative, which is x squared. The first derivative at 0 is equal to 6, and the original function at 0 is equal to 3. And what they want us to do is they want us to find f of x. What is that function? Okay, you guys go ahead and try it. To get the first derivative, I need to take the integral of the second derivative. And so that's just going to be x cubed over 3 plus c. And we know that if we plug in a 0, we should get 6. So 6 equals, if I plug in a 0, I get 0 plus c. There's my c value. So f prime of x is equal to x cubed over 3 plus 6. And so now to get the original function, I need to take the integral of the derivative, which is this right here. So x cubed over 3 plus 6 dx. So I'll add 1 to the exponent and divide by the new one, so that'll become x to the 4th over 12 plus 6x plus c. And so I know if I plug a 0 into that, I get 3. So 3 would equal 0 plus c. So there's my c value. And so my final answer here is f of x equals x to the 4th over 12. You could write 1/12 x to the 4th if you want. Plus 6x plus 3. There's my answer. So probably the most common time that working backwards gets used on like a AP test or a Central Washington test is when you talk about a position function. So that would be s of t. I don't know why they use s. But then the velocity is going to be v of t, and the velocity is the derivative of your position function. So to get from velocity back to the position function, you'd have to take the integral of this. And then acceleration, a of t, that's the second derivative of the position function. Or we could even say it's the first derivative of velocity. So if I want to go from acceleration back to velocity, I have to integrate that. And then from velocity back to the position function, I have to integrate that. And so that would be very similar to what we just did right here. Okay? All right, let's try another one. All right, so for this one, we're being asked to estimate the area under the curve using right sums and let n equal 4. So that's the number of rectangles we're going to use to estimate this area. And our equation is y equals tangent of x over x, and we're on the interval 0 to 1. So remember, we had a lot of different ways to do this. We had left sums, we had right sums, we had midpoint rule, we had trapezoidal rule. Any of those are possibilities for this test. You know they're not going to ask you more than one. There just isn't time to ask multiple questions on the same idea. So what we have to do is we have to be ready for any one of those options. All right, so you guys go ahead and try that. All right, so probably the first thing I want to do with this is maybe get an idea of what the graph looks like. And what I see on my calculator, and nothing wrong with graphing this during the test, is from 0 to 1, there's just a slight incline. Right after 1, the thing takes off and goes up. So there's an asymptote out here somewhere. But we're trying to find this area right here from 0 to 1. And since n equals 4, we're going to divide that up into 4 partitions. So this would be 0.25, this would be 0.5, 0.75, and then 1. And what we're doing is we're doing an estimate on the right side of each rectangle. So my first rectangle is going to go up like this and over. This one will look like this and over. This one will look like this. This one will look like that. So I'm going to find the area of those 4 rectangles and add them up. And I realize right away I'm going to get an answer that's too big, but that's okay. It's just an estimate, right? So for the first rectangle, I'm going to do base times height. So the base is 0.25 times tangent of 0.25 divided by 0.25. Plus, my next rectangle, base is going to be the same, 0.25. This time I'm plugging in the number on the right side, which is 0.5, so I've got tangent 0.5 over 0.5. Plus my third rectangle, base is the same. This time I'm plugging in 0.75, so tangent 0.75 over 0.75. Plus one more rectangle, I'll just write it here, 0.25 times tangent 1 divided by 1. Now I could have factored out a 0.25 and just, inside brackets, this plus this plus this plus this. That would have worked. That's how I'm going to punch it into my calculator. So get back to the home screen. Second quit, if you don't remember that, is how you get back to your home screen. 0.25. And then in parentheses, I've got tangent 0.25 divided by 0.25 plus tangent. Don't forget your calculator needs to be in radian mode. I'd fix that right now. We don't do anything in degree mode in calculus. So tangent 0.5 divided by 0.5 plus tangent 0.75 close parenthesis divided by 0.75. I'm just going to double check, make sure I'm closing all these parentheses. Yes. All right, and then plus tangent 1. And so what I got was 1.228 square units. Don't forget your label. We're talking about area here. Right? So in preparing for the test, I would want to make sure I, probably did something with left sums, did something with the midpoint rule. You can find these things in Chapter 4, either in the review section or you might have to go back and find that in the chapter. Just look back in the index. You'll be able to find all of that. All right, let's try another one. Oh, I feel like my pen gets worse here every day. FTC, you guys remember what that stands for? Fundamental Theorem of Calculus. And the Fundamental Theorem of Calculus just says that when you do an integral from A to B, you integrate this, you evaluate it at the top value first, and then subtract what you get at the bottom value. All right? So just a standard integral, really, is what it is. So this says the integral from 0 to pi of the sine of x minus the cosecant of x. You guys go ahead and try that. Alright, so I'm just going to integrate this. Integral of a sine is a negative cosine of x minus the integral of a cosecant is, let's see, that's the negative, so plus natural log absolute value of cosecant of x plus cotangent of x. And I'm going to evaluate that from 0 to pi. Alright, so if I plug a pi in first, I've got minus a cosine of pi plus natural log absolute value of a cosecant of pi plus a cotangent of pi minus what you get when you plug in a 0. So a negative cosine of 0 plus natural log absolute value, I'm not going to be able to fit it in here, cosecant 0, cotangent 0. Alright, so if I just draw a quick unit circle here to kind of help me out, here's pi, here's 0, this is the point 1 comma 0, this is the point negative 1 comma 0, and I'm in a bunch of trouble already. So yeah, so if I plug it in, cosine at pi is a negative 1. I want the opposite of that, so that's a positive 1, plus natural log absolute value of cosecant at pi. That's the reciprocal of the sine. And at that point, we are undefined. You can't take the reciprocal of 0. Right? This fraction would be equal to 0. Flip it over, and you've got 1 over 0. You've got 0 in the denominator. It's undefined. So at that point, I can go ahead and stop and say that there is no solution to this. So probably the only way this would work is maybe if I did something like pi over 4 to pi over 2. We've got some numbers here that prevented this from working. And that's always a possibility, right? We've seen all kinds of problems where we get no solution. That's certainly a possibility on the test. I'm not saying it is. Don't hear me that way. I'm just saying sometimes that stuff happens. All right, let's try another one. All right, so we want to solve each of these integrals. And really the main thing we learned in chapter 4 was basic integration along with substitution. I'm pretty sure they're not going to ask us a question on basic integration, but certainly something with substitution would be a possibility. So you guys go ahead and try these two. Alright, so with substitution, what we're saying is anytime you have something inside parentheses raised to an exponent, which that happens here and here, then I'm going to let u equal what's on the inside. So 2x minus 1. Therefore du is going to be 2, and I just took the derivative of x. So in order to put a du into the problem, I need to see a 2 dx here. So I'm going to multiply by 2, and I'll put a 1/2 on the outside. So I've got 1/2 the integral. I've got this x I'm going to have to deal with. This will be u to the 1/2, and then 2x is equal to du. So I still have to get rid of that x. Everything has to be in terms of u. And so what I'm going to do is I'm going to take this and say if I move that 1 to the other side and add it, and then divide by 2, I've got u plus 1 over 2 is equal to x. And so I'm going to put that in place of this x right here. So I now have 1/2 times the integral of u plus 1 over 2 times u to the 1/2 du. And so I'll go ahead and move this constant to the outside. Since it's in the denominator, I got to multiply it by the 2 out here. So I now have 1/4. And then I'll distribute this u to the 1/2 to each of these. So I'm going to get u to the 3/2 plus u to the 1/2 du. So now we're ready to add 1 to the exponent and divide by the new one. So that'll be u to the 5/2 divided by 5/2 means I'll multiply by 2/5 plus u to the 3/2 divided by 3/2. Still got to multiply all that by 1/4 and plus c. You know, you might notice that sometimes I put the plus c inside the bracket and sometimes outside. It really doesn't matter, and the reason for that is once I distribute this, I still have a constant that I don't know. Alright, so my last step is just to get this back in terms of x. So I'm going to put a 2x minus 1 in place of u. When I multiply here, I'll get 2/20, which will reduce down to 1/10 times 2x minus 1 raised to the 5/2. When I distribute that 1/4 here, I would get 2 over 12, which reduces down to 1/6, times 2x minus 1 to the 3/2. Distribute the 1/4 here, I still get some constant that I don't know. There's my answer. All right, for the second one, I want to think of this as the sine of 3x squared times the cosine of 3x dx. And you know, the biggest problem with this is a lot of times people look at this and they just go, oh yeah, the derivative of this is a cosine, add 1 to the exponent, divide by the new one, done. And you got to be a little more careful than that. Alright, so my last step is just to get this back in terms of x. So I'm going to put a 2x minus 1 in place of u. When I multiply here, I'll get 2/20, which will reduce down to 1/10 times 2x minus 1 raised to the 5/2. When I distribute that 1/4 here, I would get 2 over 12, which reduces down to 1/6, times 2x minus 1 to the 3/2. Distribute the 1/4 here, I still get some constant that I don't know. There's my answer. All right, for the second one, I want to think of this as the sine of 3x squared times the cosine of 3x dx. And you know, the biggest problem with this is a lot of times people look at this and they just go, oh yeah, the derivative of this is a cosine, add 1 to the exponent, divide by the new one, done. And you got to be a little more careful than that. Go through all the steps so that we don't make a mistake. If u is equal to sine of 3x, then du is going to be cosine of 3x times the derivative of the angle, which is 3, and I just took the derivative of x. So see, I don't see that 3 up here. So I've got to put a 3 into the problem and a 1/3 out in front. If I don't see that 1/3 in the final answer, then I know we haven't really done our substitution the way we're supposed to. So I've got 1/3 the integral of u squared cosine 3x times 3 dx. That's everything right here. That all becomes my du. So add 1 to the exponent and divide by the new one. U to the 3rd over 3 plus c. And multiply that by 1/3. And so what that'll do is give me 9 in the denominator. I'll go ahead and substitute my sine of 3x back in there. So sine cubed of 3x over 9. Distribute that over to here. You just get some constant that we don't know. So the most important thing here is when you use substitution, make sure you're paying attention to the angle. Okay, that's really important. All right, I got one last problem for you for chapter 1, or for chapter 4, I mean. All right, so we're trying to find the average value of f of x equals x minus 2, that quantity cubed, plus 1, on the interval 1 to 4. You guys go ahead and try it. So to find the average value, there's really just one easy step, and that's you divide by the interval width. So our width here is going to equal 3 units. So I'm just going to find the area underneath the curve and divide by 3. That's all you got to do to find the average value. So I've got the integral from 1 to 4 of x minus 2 cubed plus 1 dx. Suppose if you wanted to, you could go ahead and multiply that whole thing out. Otherwise, you can divide it up into 2 separate integrals and do a substitution. Probably either one would take the same amount of time. I'm going to go ahead and make it into 2 separate integrals. So I've got the integral from 1 to 4 of x minus 2 cubed dx. So I'll have to do a substitution there. And then plus the integral from 1 to 4 of 1 dx. So when I do my substitution, I'm just going to write it up here. I'm going to let u equal x minus 2. And so when I take the derivative of that is going to be 1, and I just took the derivative of x. So it's really just a straight across substitution. So let's see, my integral, when x equals 1, if I do 1 minus 2, that's a negative 1. When x equals 4, 4 minus 2, that's 2. So now I've got u cubed du. Now I don't have to go back and substitute any of this stuff back in. Over here I just get x evaluated from 1 to 4. See, this will be u to the 4th over 4, evaluated from negative 1 to 2. This will be plug in a 4, subtract what you get when you plug in the bottom number. So if I plug in a 2 here, 2 to the 4th, that's 2 times 2 is 4, times 2 is 8, times 2 is 16 over 4. That would be 4. If I plug in a negative 1, I'll get a positive 1 over 4. Plus this 3. So what do I have here? 3 3/4. Plus 3, that's 6 3/4. Or if I just make that into an improper fraction, that'd be 24 plus 3, 27/4. That's the area underneath the curve. And so now I just need to say that the average value is 27/4 divided by 3. We'll call that 3 over 1. So I just got to flip this over and multiply, and what I get is 27/12 units. It's not square units because we're not trying to find the area. We're just trying to find the average value along this curve. It's just some number. Okay? There it is. All right. That is what we have for today. Review from chapter 4. You know, one thing to be aware of, we learned about average value in chapter 4, and these are the kind of problems they had. But every time we learn something new, they'd go back and ask questions about things we already knew. Find the area underneath the curve. Find the average value. So would we see something like this on the Central Washington test? I think we'll see a question about the average value, but would you see it something like this? Probably not. It might have trig functions. It could have natural logs. It could have e's in it. I mean, you don't know. It could have anything. But it's a concept we want to make sure that we understand. All right? All right, let me get you an assignment. All right, so here's what we have for tonight. It's number C22, page 316. We're doing number 5, 9, 27, 45, 57, 61, 75, and 81. Hey, so real quick, some information about turning in books. Those who are not taking the Central Washington final, you guys can stop by Wilson anytime this week. Okay, I believe Monday, Wednesday, and Thursday are the 3 days. And Miss Ray should have put out some times. Wednesday's a little bit earlier, it's like 10 to 12, and then Thursday 3 to 7. Those who are taking the Central Washington final, obviously we've got some work to do still, so we need to hang on to our stuff. But almost everyone has said they want to take the 10 a.m. test, and so by doing that, that allows you to turn in your books that afternoon. So we shouldn't have any trouble there. That should be okay. If you are taking the 6 o'clock test, just hang on to your stuff. Don't worry about it. There'll be a day next week where we can get things turned in. Okay? You could turn the rest of your stuff if you're not using it, but hang on to your math stuff. You'll need that. All right, that's it. That's what we have for this week. Or no, that's what we have for today. And so we'll have one more review tomorrow and our Central Washington exam on Thursday. And I won't have anything next week for you guys. I doubt that anybody would do it anyway. So yeah, when we get to Thursday, we are done. All right, have a good day. Stay safe.